Hello students. So in the last class I was discussing about what is a radioactive material, how many types of nuclear radiations are there. There I discussed about alpha, beta and gamma radiations. I discussed about this type of nuclear radiations. Now in this lecture I am going to discuss about one of the method for detection and measurement of these nuclear radiations. So Geiger-Müller tube is one of the method. I will be discussing about two methods like Geiger-Müller tube and scintillation counter, and these are used for detection as well as measurement of nuclear radiations like alpha, beta or gamma rays. So let me tell you the construction of Geiger-Müller tube. So this Geiger-Müller tube consists of cathode. So this cathode is basically a metallic cylinder. This Geiger-Müller tube consists of cathode, and this cathode is a metallic cylinder, and it consists of a fine wire which is running through the center of the cylinder, and that is the anode. And this whole cathode and anode, this whole arrangement is mounted inside a very thin walled glass envelope. It is an evacuated glass envelope, and which is sealed from one end by a window from where the nuclear radiations may enter this tube. Now this whole glass envelope, the air from this whole glass envelope is evacuated, and a gas like argon gas is inserted into this arrangement, into this glass envelope. Now we have there is a voltage which is connected between anode and cathode. Now since there is a gas inside, like argon gas is inside this glass envelope, inside this arrangement, so the voltage is kept at such a value that it is lower than the ionizing potential of this argon gas or whatever gas is inside this arrangement. So the voltage that we are going to apply between anode and cathode, it is lower than the ionizing potential or ionization potential of the gas inside this envelope, glass envelope. So now what will happen when the radiations are going to enter, when the nuclear radiation are going to enter through this window into this chamber, into this glass envelope? What will happen? As I have told you, this alpha, beta or gamma rays have the ionizing potential. They can ionize the atoms that they come in contact with. So whenever this nuclear radiation is going to enter this glass envelope through this window, what they will do? They will ionize the gas atoms. Now once the gas atoms are ionized, what will happen? Since this anode is connected to the positive terminal of the battery and cathode is connected to the negative terminal of the battery, so the negative ions will get attracted to the anode and the positive ions will get attracted to the cathode. And during this journey, when this ions will move towards the cathode or anode, that is the negative ions, when the negative ions are going to move towards the anode and the positive ions are going to move towards the cathode, during this journey they are going to ionize more gas atoms, and this process of ionization will keep on going on. It will continue to be this process will keep on continue for an indefinite period of time, and because of that whole gas atoms will get ionized and will get a pulse of current through this tube. So how now this pulse of current, now it is flowing through this resistance. There is a resistance which is connected in series with the anode and the battery. So when the ions are moving towards the anode and cathode, that is more and more gas atoms are getting ionized. So we'll get a pulse of current through this tube, and this pulse of current, that is very high amount of current, all of a sudden this pulse of current will flow through this resistance, and therefore a voltage drop will occur across this resistance. So this voltage drop, if one alpha particle is entering the Geiger-Müller tube, then we'll get to see one peak of current, one pulse of current, and then one pulse of output voltage across the resistance. In this way, if we apply some counter across this resistance, and if we count this number of pulse, we'll get to find the number of particles that are entering this Geiger-Müller tube. So as I have told you that once ionization is established, this process is going to continue for an indefinite period of time. However, since resistor R, which is having a very high value of resistance, is connected in series with this anode and battery, that is when the gas ionizes. So when this resistor, because this resistor is connected in series with the anode and battery, so when the gas ionizes, as I've told you, a very high or very heavy current will flow through this resistance, causing a large voltage drop, and this voltage drop is sufficient to reduce the anode voltage much below the ionization potential, and this will cease the ionization process inside the Geiger-Müller tube. So now if the radiation enters the tube, again if the radiation enters the tube, the ionization will start, and a current again flows through resistance R, giving an output voltage. So this way a series of alpha or beta particles or gamma radiations or burst of gamma rays, they cause a series of current pulses to pass through the anode circuit of the tube and hence through the resistance. So the output pulses from this resistance, they may be amplified, as I've shown here. We have used a vacuum tube amplifier also. So the output output pulses from this resistance, they may be amplified and is registered by a counting device. So by counting the number of pulses, we can know the number of particles that are entering the Geiger-Müller tube through this window. So the number counted, it gives the intensity of radiation, that is how many particles are entering per second. So this number, the number of pulses that is registered through this digital counter can give the intensity of radiation. Now the pulses may be stored in some cases, and the total count may be calibrated in terms of radioactivity. So this is how, in fact, in this Geiger-Müller tube, this ionization takes place, this complete ionization takes place in no time. And the counting rate of this Geiger-Müller tube is greater than 10 to the power 3 counts per second. So this is all about the Geiger-Müller tube. That is how it counts, how it detects the alpha, beta or gamma radiations, and how it measures this number of radiations or the intensity of radiation. So in the next lecture, I am going to discuss about scintillation counter. This is also used for the same purpose like for detecting and measuring the nuclear radiations. I am ending this class here. Thank you.